Start the
This
recording.
conference will now be recorded.
Thank you. Okay, so let's start with today. So it's a quick introduction today, just to get to know about the different AWS services, why AWS came into picture, and how it progressed throughout these years. So let me just see if my screen should be visible. Let me make it 100%. Yeah, it should be good now. All right, so let's start with AWS history slightly, quite a bit. So how did AWS actually, it was an internal to AWS, these features, they adopted to cloud computing initially internal within Amazon. So Amazon, like we know, they had a list of services with them. They were working with Kindle, they were working with product deliveries. They had their own core services, which they were replicating across different countries. Now they were managing everything onto the servers, right? They had all physical servers, they were running onto it. So they always wanted to move into cloud, and that was always there in back of their mind. So that's how this idea came into picture. And then it took over the 10 years in the making, they enabled sellers on Amazon. It was required for internal need for scalable deployment for the environment, and it was required to prove developers were hungry for more. So mainly they wanted it for their own infrastructure because Amazon was struggling to deliver at that time as a fast pace because it boomed like anything for Amazon, and their sales were rocketing at that stage. So what AWS wanted at that time, so what its mission was when they started it, so they wanted something which enables businesses and developers to use web services to build scalable, sophisticated applications. So mainly they wanted something where people don't have to dig into servers, they don't have to know the hard coding stuff, they don't mainly go into servers, so everything can be done from a web. And one of the guy actually presented one of the papers long back where they actually said that in some time they are going to run it through a web service. So a white paper was released from then the Amazon CTO actually, who actually said that they are going to run it soon on Amazon Web Services. So these were the design which they came up with. So it consists of different services. So they have deployment and administration. They have app services, which relies on the AWS Global Infrastructure. So what it contains, you have compute nodes, you have storage, databases, and networking. So this is something which is heart and brain of their system. So everything runs on top of it. The app services run on top of these, and your deployment administration runs on top of this. So AWS Global Infrastructure is something we'll be seeing in upcoming session, where it deals with the number of regions, or in the upcoming slides actually, where it deals with availability zones, number of regions, and few other things. So this was the design basically which was put across, which AWS uses global infrastructure. They'll be using networking components, the compute, the storage, and the database, followed by app services and deployment and administration. Okay. So this is the older one. Now AWS has 13 regions as of now. They have more than 52 edge locations and more than 28 availability zones. And this is upcoming. So they do have something planned as well. So which will be coming up soon in the upcoming years. They are going to expand it within US region, Europe region. They are going to expand it across APAC and Asia as well. And they do have plans something to put on Africa, which doesn't have anything as of now. All right, so this is how AWS Global Infrastructure looks. So this is important because that's something we will be doing as a part of our first practicals. That's actually when we do it. So let's see that what this means. So when you say AWS Global Infrastructure, it consists of regions followed by availability zones. So at the very high level, you have something called regions. So you see something on this dark brown right here. That's your region. So region is the main component with inside that you have everything. Now within a region, you can have many availability zones. Now all the regions by default should have 2 or more availability zones. Now depending upon a region, it can have numbers of availability zones. The maximum as of now is US Virginia. So US Virginia is one of the regions which has 6 availability zones as of now. So that's the maximum. Otherwise, most of them consist of at least 3 availability zones. So how does this availability zones look? So let's say this is within a region. You have availability zone A, availability zone B, C, and D. Now these availability zones itself consist of data centers, right? So it's it's a region, and then you have availability zones, and within that availability zones, Amazon have their own data center. So AWS, they have their own data center. Now these data center addresses, they are kept confidential, so they are not released in public. They are not released to anyone. So they are more like secret locations where they have been kept. But within an availability zones, you can have multiple data centers located. And the reason for that is because they do require replication of services. So if your data is residing in one of the availability zones, they need to have data center where your application services, your infrastructure can be replicated to provide high availability. So that's how data center, your availability zones and regions are being designed. Now to remember that there are multiple regions within AWS Global Infrastructure. Like we have discussed, it's more than 13 is what we have. Let me quickly reduce a size little. I'm finding some issues while trying to scroll it. So let me quickly do that. Yeah, should be good now. Okay, so it powers most of the businesses. As we know, AWS is everywhere. You have quite number of clients, as you can see on the screen. You have Workday using it, LinkedIn is running on that, Pinterest, Instagram, Airbnb, Hangama.com, FunPlus. So all these listed, and this is just tip of an iceberg. So you have quite number of clients working on that, and you can find that even in case studies. So if you go to AWS website, and if you have a requirement where you want to run your website on S3, or you have a specific requirement, you will always find a case study for one of the clients or few of the clients who have actually done it. For example, Netflix. So Netflix is someone who is running all their video streaming service just on S3. So these kind of case studies is something you can find right on AWS website, and they'll tell you how they did it. So how the architecture was developed and how they implemented that solution, how AWS implemented that solution for them, and they are running profitable business now. Okay, now they do have public sector as well, which consist of quite number of universities coming in. You can see Coursera right there. You can see University of Australia. You have universities from US as well, and as well as there are quite number of government services as well. So like we know, AWS is the only cloud which runs GOV cloud for US government. So they do have that, and then number of public universities, number of public research organizations, they do run on AWS. Okay, so AWS is the overwhelming market, which you can see, and it shares more than 5 times the compute capacity in use than aggregated total of all other 14 providers. Now you can see the 14 providers listed on your screen, but there are quite number of more. You have more than 100 clouds present in today's era, but AWS, you can see it's right on the top. Okay, so you don't see, so this is something which is not design rate, but you can see that it is clearly a winner. So it's right at the top leader, and then there are other clouds which you can see in Zunk they have placed elsewhere. Like Microsoft has came up quite close. I mean, not so close to AWS, but yeah, that's the second one comparing to AWS. So you have AWS followed by Microsoft, and then there are others: DigitalOcean, Rackspace, CSC. So quite number of them. So now Alibaba has also entered recently. I think probably about 3 or 4 months back. Alibaba is actively promoting their own cloud, and they are promoting it heavily. So yeah,
Who
that's
is
another competition.
who is
Yeah.
Alibaba?
Yes, Alibaba is another company, which, if you would know, you can, buy most of the stuff from there. The worldwide, you get one of the cheapest stuff there. So they are actually one of the retail companies so far. Most of the Chinese products is what being sold onto their website, and now they are getting into cloud. So I think probably 3 months back or something, they have announced that they are moving into cloud, and yeah, they are providing trial for them. So that's also getting into the market now. So it's one of the providers, another providers who is getting into cloud now. So it is one of the big businesses. They have one of the most retail businesses across the world. So he is one of the greatest guys. He has launched from scratch, and he is doing good. So he is in a similar line to Amazon. So the way Amazon was started, they started small and they turned into leaped and bounds. They moved further, and that's how Alibaba is doing now. So they are also getting into market, and then you have Microsoft, Rackspace, DigitalOcean, Oracle is also coming into picture. Google is also coming into picture. So you have IBM, and there are various others. But yeah, AWS is the leader. The reason for that is they have numerous services available, which many other clouds still simply lack it. Now, AWS came into picture quite early, and that's why they have most of the services available, which other clouds they don't have that. So most of the other clouds, what they have right now is compute, networking. They have these region concepts and all. So mainly the compute, networking, database, storage is what they are coming with. But there are other variety of services which AWS comes with, which other clouds they don't possess them still now. So yeah, there is a competition in market, and you never know which one gonna go further. But as of now, AWS reigns right clear. So they are quite ahead comparing to any other cloud in the market. All right. So on an average, AWS adds enough new server capacity every day to support Amazon's global infrastructure when it was 7 billion business 2004. So 2004, when they started, they would keep on adding servers, every day for their growing business. They were doing that. So that was the perspective for the scaling. Now they wanted something on demand, which is uniform. They can use something as pay as you go. Available is what was there in back of their mind. So this is what they faced over the period of time. So the line in red is what you see is the capacity. So that was the actual capacity which was bought, right? So and it's not only for AWS. You can consider it for any other company. So someone buys a server, so they have a fixed capacity. So if you see on this picture, you can see that red line is your fixed capacity. So you have bought these many servers, so you have that much infrastructure available to you. But now when you actually run your application or your services, the blue line which shows you the actual usage. So that's the actual usage which you need. But you do have additional capacity available, which is simply getting wasted. Now, why? Because you cannot exactly calculate what you need. So even if you try on and off your servers, or you want to go for a faster growth, you want to identify variable peaks or predictable peaks, it was not easy with the traditional infrastructure. The reason was pretty simple. So you need to buy something as fixed storage. So it can reach to peak. Sometimes it may be higher, sometimes it may be lower. If you suddenly wants to upgrade your servers, then you don't have that capacity. For example, let's consider one of the e-commerce website. Now this e-commerce websites, they are running a promo, and let's say during a Black Friday, they are promoting it heavily, and then they got maybe 10x more users coming onto their website. Their website cannot rely on that, and it simply crashes. And it has happened in the past to many of the vendors. So that was really a pain for most of the IT giants, that they either they need to buy more capacity, which they won't be utilizing for another year, or they just need to buy maybe additional for that particular day, which doesn't make sense to put that amount of money. So yeah, it has a lot of pains in terms of fast growth or for predictable peaks, in variable peaks. It was simply not identifiable using your traditional environment. Now, what happened with AWS? Those things got changed. So the one picture you saw just above, the red one was the fixed capacity, right? So this was the fixed capacity. And when we came into AWS, the gray one, so the fixed capacity was gone, and you are actually using what you want. So let's say if you are working in an environment where you're working with variable peaks, your AWS exactly covers that. So the one in orange actually covers your requirement. So if you are in peak, it covers you right at the peak. If you're just below peak, it covers that. So on and off, it covers both. If you want really fast growth, so maybe you need servers for a couple of days, let's say your Black Day sale, it can be covered right here. Or if you need maybe something in upcoming in 3 months, and then you don't want to use it after 3 months, so you can use that for 3 months and then you can deprecate it. So those kind of facilities were available when you work with Amazon. You can predict your peaks, so exactly the way your peak goes. Whenever you need higher amount of infrastructure, it comes up. When you want lower, it lows down. So all these facilities were available when you work with AWS. So mainly it was actually calculating what you need. So there was no wastage of resources at all. Now, another best part when you work with AWS is, let's say you need one of the servers. So you created an infrastructure, you created one of the compute nodes, you have deployed all your services, and you have done everything. So everything, all your businesses are running, let's say, with one server, and you're good to go. Now all of a sudden your company got huge investment and you are going to expand. So you just need to, maybe you have another 1 million users coming in every day, which were just probably about maybe 50,000 or users earlier. So now you're getting more number of users, you need to expand, and buying servers, procuring it, signing a contract is a really big deal, and it costs you a lot of money. And mainly it's a slow process. So maybe if you have plans to do that, you may be looking for a timeline for a 3 months to 6 months time. But when you're AWS, that something can be done within days. So it can be done within days. So you can expand from one compute node to 1,000 in a day's time or a minute if your team is really efficient. So that was possible with AWS. Right. So this is something which was for Amazon.com. So that's
How
something
do
they did
in a high level, how do you do that expansion?
Right. So how do we do that expansion? It's quite easy. So when you're in AWS, let's say you have created this configuration, and that's something we'll be seeing. So if you have done this and all configuration you have done it, you can simply clone this. Or what you can do is you can create an image out of this, which will be
Okay.
exact replica of your this, and you can use that image to spin up any number of servers. So that's
Okay.
easy that way. While with the on-premises, that's not easy. That's not really easy. You can't do it simply that way.
If you can buy servers, configure them, and stuff like that. Okay.
Yeah, so that's difficult. While for AWS, you don't have to do this. You just created one image and you can spin up another server just with the image. And that's something we'll be doing it when we do it for EC2, and we'll see that how easy it is to do that. All right, so this is a November traffic for Amazon.com, something which they were noticing. So that's how their peak load was. They were initially down, and sometimes, during the end, it was require hiring. So that was the actual peak load which they observed over the period of time. While that was the peak load, their provision capacity, which can see in the blue, that was their actual capacity. So you can see that your peak load, the load which was running on Amazon.com, and the capacity they were using was not in sync. So mainly what they noticed is they're only utilizing 24% of the resources, and 76% is getting wasted because they just had few days where they wanted close to their provision capacity. Otherwise, most of the other days it was simply getting wasted. So 76% of the resources were getting wasted, but they still had to run it because that was the only choice. And that's why they wanted to get that into cloud. So that's when they decided, and they were already in the picture. They were already working on a there were a team within Amazon.com which were working for this cloud, and they were trying to run their systems. So on November 10, 2010, is when Amazon.com turned off their last physical web server. So that was the time they completely moved into AWS. So the data center, the all physical servers which they had, the last server was turned off on November 10, 2010, and from then on, everything was running onto AWS Cloud for Amazon.com. So that's something they did for their own. And that's how the new picture was. So once that was done, they did notice that their provision capacity and their actual usage are completely in sync, and they are not even wasting a 0%. So there is no wastage at all. So maybe just few, but it's really really good. So something from 76% which gets reduced to maybe 2% or 5%, it's really good. So that's how Amazon.com did it for themselves, and which gave them confidence to release it to the public so that they can use it and then they can utilize the same. Right. So why are customers adopting cloud computing at AWS so quickly? So we saw one of the reasons why AWS moved into it. And if AWS has moved, Amazon was a really big company, and they have moved all their infrastructure from on-premises to the cloud. And that gives a good boost to anyone in the world to do that. Okay, but there were some reasons which they have to put in front of the customer if they want to sell it. So first was lower cost with AWS upfront and increased saving as your usage grows. So they had different pricing available. So first thing was, if someone wants to try it, they have pay per use. So pay as you go. So it's like your prepaid mobile. So you fill in your mobile, you use it for the time you want to, until the time you have money, you can use it. Or they provided customer with the upfront pricing, where the same server, if they pay an amount for it, that will be costing them up to 70% less. So how do you calculate that? For example, one server which you're using, and you're paying it for hourly basis. An hourly rate is, let's say, $1. I'm just giving you an example. It's exactly not $1. It's quite less than that. But let's say it's cost $1. So for 24 hours, it's going to cost you $24. And for a 1 year, it's going to cost you 24 into 365 days is what it will be charging you. But when you pay something upfront to AWS, that's going to cost you 70% less. So maybe you are looking at something really 70% of that amount. So that's how they started selling that product. So you can replace upfront capital expense with low variable costs. Otherwise, economies of scale allow us to continually lower costs. So they were still reducing it. So when they will launched it, at that time, it was a little higher in terms of pricing, but then they will keep on working on it to reduce it. Again, the pricing model, they gave customer choice. So they gave something called on demand. They said reserved, and there was spot pricing as well. Now we will see that what these are. But for now, on demand is something you use it and you pay for it. For example, you're using it for 1 hour, you pay for 1 hour. It's like the older traditional world we were using internet. You go to cyber cafe, you do it for 1 hour and you pay for that. So that's how it was. Otherwise, there was something called reserved. Reserved is where you pay upfront cost. So customer pays upfront cost, and it is like reserve where it's reserved for you. So it's a dedicated machine for you, and you are the only one who will be using it on your infrastructure. But it will be cheaper, so you'll be paying quite less price, and that's good for the customer who are looking for a long term. So if you know that you are going to run your configuration for 1 year or 3 years, you can pay upfront cost, which will be cheaper than on demand. And then there are something called spot instances as well, which was available at that time. And what are these? These were more like bidding instances. So if it was not for running your production environment, but let's say your developers or your tester wants to test something for some few hours, right? They can bid for a machine, they win it, they will run it, but these were not available to you, because as soon as someone else bids for it, little higher amount, it will be transferred to them. So yeah, it was good for small usage, but it's still good because you are getting servers for a cheaper price. You are bidding for it, so it's good. And then there were tiered pricing, custom pricings, and volume discounts, which was available to customers. So it really a great deal for someone who wants to test it and have them available. Okay, then later on April 1, 2014, because 2010 is when AWS was running it, and later it was released to public, and then they further reduced their prices. So they got to know, they can further get it cheaper. So S3, which was a storage service, that was reduced up to 51% on average. So price decreased from 36% to 65. EC2 instances, which is your virtual machines, that's our first topic for discussion as well. That was reduced to 38%. Your M3, which is a high configuration, and C3, which is again your M1, M2, C1, and C3. All these are high configuration virtual machines, and we'll be seeing that why they're called high configuration, because they do carry enough number of CPUs. They got high CPU powers in terms of memory. They carry high memory capacity. So yeah, those were also reduced. And if a customer is running, definitely they'll be looking for higher CPU and high memory. And if it is getting 30% reduction, that's a boost. In terms of RDS, which is your database, most of the clients earlier were using relational database systems by 2014. And later on, NoSQL came into picture. But yeah, most of the clients at that time were on RDS, which was reduced to 28%. Elasticache, which was again reduced to 34%, and EMR again was reduced to 27 to 61 reduction. So as along the way, AWS found out that they can further reduce their pricing. They were working on it, and they did that for the customer. Now, agility is one of the reasons that customer do like moving into AWS, because it's really easy to change, and scale it. It's elastic. So mainly your AWS cloud is really elastic. If you want your product to be delivered faster into the market, AWS is the way to go. So agility was one of the reasons client did prefer AWS, moving into AWS.
What is
So
the meaning of agility?
So mainly you have earlier in the earlier development scenario, you have something called waterfall model. right? So if you will know that there was a waterfall model, and later on agile model came into picture where you had recurring processes. So waterfall model used to follow, you take a business requirement, then your BA or business analyst will take this business requirement, they'll transfer it to developers will take that design, a design will be performed, specification or design will be done, and then your coding will be performed, then testing will be performed, and then finally your code moves into production. So that was a process earlier, but that has its own glitches, right? So it has problems because let's say if the business requirement was wrong or design was wrong, the end product will suffer. And that was happening. That happened to quite a number of clients. Now, agile development came into picture where it was a recursive process. So that means if you have done the specification and design, it goes to the next process and then it will be re-evaluated. Okay. So if there is something wrong, they're going to re-evaluate it, they're going to make corrections and then do it. Because how it works in a software development lifecycle, the earlier you find the problem, the lower cost it's going to get you, and you will have more customer satisfaction. So if you find it at a last stage, let's say when the product is actually developed or when the product is released, and you find the problems with the product at that time, you're going to get customer dissatisfaction and you're going to suffer a lot. Maybe your product can get rejected simply. So agility is mainly a way through which you will be able to deliver your product and services to the market faster. So with a waterfall model, it used to be slower because you have to process, follow everything. While with agile, when you're agile, you can deliver your product and services to the market, and that's what the agility means. You are faster to the market. So you're agile. You know different ways to get to your where you want to be. So that's what it means actually. So that's why I said why it matters. It's simple because you want to move up to the market faster. So it was used for different websites. So University of Notre Dame, they used it. It was used in campaign for US elections. It is also used by NASA for video streaming and used by New York University as well. So quite a number of vendors who uses it. Now, so this is another reason why it was used, because old world, as you know, infrastructure. I mean, I have worked in, you would have worked in, and anyone who have worked in probably about 10 years back or something, they would know if there was a requirement, if you have to create a production server or a testing server or a development server, yeah, it does take time. Whenever they require a server, they will ask your operations team how long it's gonna take so that they can start working on the assignment. And operations team used to say, okay, this also, what's the configuration, give me the capacity requirement, all these, everything they'll take in place, the budgeting, everything comes into picture, and then they say, okay, probably about 1 week for development, maybe 2 weeks for testing, and 4 weeks for production, because that's crucial. But all in all, a server, or which comprising of your server, your databases, your web server, your application server, you're the actual blade servers, everything all together, there were times when it even used to take weeks or months as well. So there was a time when server was released even in a month's time. So it was slow, pretty slow. So someone within a month's time, maybe you can release your product, but your server itself is taking that much amount of time. So for such reasons, you needed something really fast. So in older configuration, infrastructure used to take in weeks, while if AWS, if someone asks you for a server, you just need minutes. You don't even need days for that. But let's say if they really want a high configuration with all architecture and all solutions, maybe a day or two, but nothing beyond that. So yeah, it's easy. It's quite easy working with AWS. Right. So what it does, so AWS enables IT to deliver infrastructure within minutes. And when you say minutes, it is same for you to release a small configuration or the bigger configuration. So something with 1 GB of RAM and one core of CPU can be released in minutes. Similarly, let's say 12 cores machine or 16 or 32 cores machine and 16 GB of RAM or 128 GB of RAM or 256 GB of RAM, anything can be delivered within minutes. So everything is same. You just need a server, you need to choose your configuration because it's a web service and you're not actually doing it. You're not putting in the DIMMs, you're not putting everything on the server. So everything is virtualized. You're just choosing your configuration and you can order that in minutes. So that's easy it is. Now you can add new test dev environment within minutes. You can add 50 servers for test dev within minutes. So you can add new DR environment on West within minutes. You can add hundreds of servers for traffic within minutes. You can remove servers, hundreds of peak remove servers. So if you have 1,000 servers running during peak hours and you don't need them during non-business hours, you can simply remove them. You can deploy
So,
10,000 cores of GIS clusters, or
so
you know,
all of
yeah,
these servers, Christian, all of these servers that you add as you go along, you are being charged, right?
yeah. So once, so what you're saying is once it is removed, we are not going to get charged, right?
No, I'm asking that as you walk along, as you add these services or servers, you are being charged, right?
Yes, yes, that's true. So if you're adding more number of servers, you would be getting charged for it. So it all depends upon how much resource you are using. But if you are on demand, then you'll be getting charged on per hour basis. But if you have already bought it, if you have paid the upfront cost, which most of the IT organization does, then it's further gonna get you cheap and you'll be getting it for 70% less.
Okay.
So yeah, but any servers you add, you would be getting charged for it. That's for sure. Okay, so yeah, so AWS, when they designed it, they designed in the concept. So that was the first design. So even when they came for the AWS for the first time, they knew that any service you create, and it's true for the world, that anything you create, it is easy for it to fail. So there is always risk. Something which you design, it may fail. So that was for the reason they came up with the option of replication. So they knew that if a server is created for someone, so let's say a client created a server and then they were working with the server, that server can fail. So they knew about it, and that's how they designed their infrastructure. And for that reason, they design all these replication, availability zones, regions, and all that into picture. So what AWS does and why client trust AWS, that's for the reason because one of the servers you create, or hundreds of servers you create, or thousands or 10,000, any number of servers you create, those servers are always, there will be backup available for them. So you are not paying for those backups. So that's the good thing if you are on AWS, because you're running your servers and you have all the configuration there, and if it crashes and you are using something called auto scaling,
Mhm.
those servers will be available to you. So immediately those servers will be cloned for you, because that something got crashed for some reason, for some unknown reason on the AWS servers, mainly the AWS services. Those servers will be kept cloned for you, and when as soon as the server is down, another server will spin up exactly with the same configuration. So that's how they have designed AWS. So you're never ever going to lose your data, and you are never ever going to lose your servers ever. So that's the best part, and that's why client trust AWS for that reason. And it's like 99.999, and they have that redundancy level available to them. And it's at all levels. It's at server levels, it's at storage level, it's at database level, it is networking level. So it's at all levels. So they do have that. Okay, so what are customers using AWS for? So let's say someone who is coming new to AWS, they should know what all they can do, or maybe for a client, they should know who it is good for. So this is one of the use cases that was for University of Notre Dame. So they used AWS for this reason. So they had something called BCS Game Day. So all of a sudden there was a spike, and they knew that there will be a spike on their website, but they don't want to buy additional servers, such as buying a new server, procuring it, paying for it, and all. So they did that on AWS, and they were able to scale up to 500% increase in their traffic. So comparing to what they usually get, they were able to accommodate 500% within a day's time. So that was easy. I mean, and very next day they don't need that. So it's simple as that. So if you have such a requirement, it's good. It makes sense to be on AWS. Similarly, NASA, it uses it for image processing and streaming of the Mars landing. They use AWS for that. They had those servers capacity available, and these are some of the things which they use. So they use Nginx Edge Cache, they use Adobe FMS, they use Amazon Elastic Load Balancer. Now, why do you know load balancer? Because you will have numerous EC2 instances running behind it. And then they make use of CloudFormation stack, and those are the things which we'll be discussing later on. But just for now, these are one of the case studies which shows the clients which have actually used AWS successfully. All right, it was also used during Obama's election. So when by US government during their election, they did make use of AWS for promoting, for targeting, for call tool, for their dashboards, for volunteer management system, for donor collection system. So they did use it for that purpose as well. Right. So that was about what AWS can do, why it came into picture, what was the reason, what are the advantages. Now we'll go through AWS service overview, which actually will tell us what we will be getting into as a part of this course. So what we will be dealing with, and all these clients, they run it, and if we would be able to run all those configurations. All right, so we are going to start with AWS service overview, which gonna get with a glimpse of all the services which are available in AWS and the services which will be part of our discussion as a part of our course. Let me see if I just, okay, so I'm in the next slide, that's good. So first in our kitty is networking services. Now, as we have seen it even during the demo, so networking services actively uses Amazon VPC. That's where your all infrastructure lies. So you do have regions, you do have availability zones, but you do have something called VPC. VPC also is also known as your private data center within your AWS. So few people do call it, it's more like, because that's something where you create all your resources. So you create your EC2 instances, your networking components, your firewall, your security groups, everything within that infrastructure. So VPC is actually where you create most of your resources. So if you're creating EC2, if you're running your applications, so your web servers, application servers, your database servers, everything, you keep it inside VPC, and it will not have access to anything outside VPC until you want it to. So you can restrict it to have all the access internal to VPC, or if you want it to have connection to internet, you can certainly do that. Just give me a second. I'm seeing my battery getting a little down. Let me just plug in and I'll come back in a minute. Just give me a few seconds. Okay, I'm good. Okay, so another one is AWS Direct Connects. So that's a way, and that was designed for the reason because there are few customers, or maybe they are not very eager, or they don't know much about AWS services as of now, but they may want to move into it, and before that they want to test it. So for such customers, there are variety of ways. So maybe they want to transfer their data. You can use something called AWS Direct Connect. So if they're moving into AWS, first thing is they need to move their data into AWS Cloud. So there are a number of ways to do it, and people do use number of ways. So one way is to use something called Direct Connect. So how does it work? So there is an appliance within Amazon. They will provide this appliance. Maybe it's for storage, or it's for database, whatever. So let's say if it is storage, they'll use that storage appliance and they will put it between customer and AWS, and that's how they are actually connecting on premises to AWS cloud. So few of the customers, because these are the real case studies where few of the customers, although they have their confidential data, they want everything to be run on premises, but they still want storage to be available on AWS. The reason being, storage on AWS is redundant, it's cheap, and it's easily manageable. So you have that reliability features available. You can scale it up and down as and when you need it. So it's really elastic. So maybe customer, they are running their servers, web servers, application servers, all their websites, all their infrastructure on premises, but storage is something they still want to put on AWS. It may be their logs, it may be their dump files, or it may be some 10 years old data, or 20 years, 150 years old data. It's something which they want to dump, for which they are paying high storage, or for maybe one of their clients such as EMC or any of the storage vendor which they are actually paying so far. So maybe they just want to dump that data onto AWS. They can use something like that. But Direct Connect is a way through which they can connect to one of the on-premises and they can do even data transfer. So that's been
So
possible.
are we going to do an exercise like to transfer data from on-site to cloud, right?
Yes, it is. It is possible. Yes, you can do that. And there are other ways as well. Sometimes, let's say one of the customers, if they don't really want that, so they don't want to transfer data this way, or maybe there is a massive amount of data, which may be, because when you connect through direct connect, maybe there is a bandwidth which they are not happy with. AWS provides you with another feature called Snowball. So Snowball is more like you order it, and one of the AWS vendors, they will go to on-premises data center. They will pack up all the data, they will put it into Snowball, and that will come back to AWS, and then they will load it. So there are different ways. It's again depends upon organization what they want to choose it. But the
So
direct connect is one of, yeah.
we're going to cover this in the course, right?
Yeah, so we have this direct connect and all. Snowball is not covered because it uses really petabytes of data, and we will
Okay.
not have that amount of data. But we can tell you how it will done. Like I've told you, it is being used one of the services. But that simple service, you don't do anything actually there. You just have to request it. So let's say you are one of the organizations who want to move your data into AWS Cloud. You will be ordering it from AWS Console, one of their partners, or maybe AWS, someone from Amazon. They'll come to you with a device where you'll be feeding on your data, and it will be securely transferred to your cloud. So that's about it. So nothing much. So mainly it's a service which they provide. So another one in the networking is Amazon Route 53, and this is one of the interesting service. Okay, we do have one more service which is again part of your networking service. Now it is not covered in networking service because it's called content delivery, which is CloudFront. That is something we are covering as a part of our course. And Route 53 is also we are covering as a part of our course. It is domain name system. So that's where it decides. So mainly you want to redirect your traffic from the internet to one of your websites, or maybe you want to perform caching using CloudFront. You want to perform content delivery, or you want to provide that traffic to your ELB. All those things you can do using Route 53. So Route 53 is actually your domain name service. So maybe you want to buy a domain, you can do that. And using that domain, you can do network traffic control. So you can decide how traffic should flow from that particular domain name to your servers or to your environment. So that's something you would be able to do it in Route 53, which is part of your networking. Okay, so that's about networking services. Next in the list, we have compute services, which will be our primary point of discussion. That's how we are going to start. So we'll be starting with EC2. That will be our first topic once we are done with all these slides and everything. So Amazon EC2, that's your elastic virtual servers in the cloud. So we can create Linux or Unix on Windows machine, for which we have already AMI available. So we have pre-configured AMI which are available, and we can use that to configure to create our EC2 instances. Additionally, we do have some other AMIs available, and that's something we'll be seeing when we create EC2 instances, so that it will be visible to you, and then we know what I'm talking about. But for now, just remember that there is something called AMI, which is called Amazon Machine Image. Using that image, you actually spin up your servers. So you create a Windows machine or you create a Linux machine using AMI. And AMI, we will also be learning as a part of our mini assignment, that how to create an AMI from your existing servers. So once you create a server, you create a configuration. We'll be learning how to create an AMI, and then you can use that AMI to further create your number of servers using that AMI. So that's something we'll be doing it. All right, then there is another one within compute node, which is called auto scaling. This is another most of the advanced features. It does comes in management tools, and the reason for that is auto scaling is one feature which gives you a way to scale up or scale down your servers instantly. So like I said, I was just giving you an example. So you have two servers running, and you said your server configuration should be between 2 to 8. So you know that during non-business hours, you just need two servers to support your customers, because maybe just hundreds of users, they log in during non-business hours to check it. But during business hours, maybe let's say morning 9 to evening 6 or evening 8, whatever. So during that times, you have all the employees coming in, and maybe there are 50,000 users who will be logging into that. So at that time, you need 8 machines to be available which can support these many users. So you will be using something called auto scaling. What it does, during non-business hours, it will be just running two servers. And as soon as business hours start, it will automatically expand it up to 8 servers. So every day it will be running 2 servers during non-business hours and 8 servers during business hours. Apart from that, so that's about scaling the capacity or providing elasticity. Apart from that, it also comes with one additional feature. Now you may ask questions that, okay, let's say during business hours it has to support 8 servers. But what if 2 of the servers or 3 of the servers get crashed for some reason? That's where auto scaling is really handful. In case out of 8 servers, 3 servers goes down, you will have other 3 servers, replicas of those 3 servers available instantly within minutes, which will be covering for those crash servers. So as soon as those 3 servers are down or it is crashed, 3 new replicas of that server will be created. So all the time you will have your server capacity, which you have mentioned. So during non-business hours, you will always have 2. Even if your server get crashed or shut down, it will automatically create 2 others, and those 2 servers always will be running. And same for non-business hours, always 8 will be running. Now, in case you want to more servers, then you have to specify it in configuration, saying that you need something more than 8 servers or maybe less than 8 servers. That's up to you. But whatever number of servers you have mentioned, you can rely that's the reliability what AWS provides, that you would be able to run those many servers all the time. If there is a crash or shutdown or termination, it will be taken care by AWS and you will be provided those servers instantly. Right, and there is no charge for it. So you will be you will be getting charged only for the resources you are utilizing. That means the 8 instances, EC2 instances which you are using, you will be charged only for that. All right.
Okay.
Next is your elastic load balancing. Now this is another good feature. What it does, so you may have number of servers, but you need an endpoint, right? So maybe you have a website which will be hitting you, and you'll be supporting your servers through that website. So if today, let's say there are 200 users coming in, and maybe during a sale day 500 users may come in, or maybe during another, over the period of 6 months you are expanding your business and more number of users will be logging in. So if you are finding such a scenario, you have an ELB which controls 3 EC2 instances, right in the picture which you see here. So you
Uh-huh.
have these 3 EC2 instances. Now, in case you have to expand your business and you need more number of EC2 instances, you can simply clone these servers and you can add additional servers as a part of ELB. So from 3, you can make it up to 6, 10, hundreds, whatever. So depending upon how many clients you're coming in, you can simply do that instantly. So you don't need, much wait time or anything. You can simply clone this server using this cloning of, because you, again, at the end of the day, you need same server and you just need it to be part of your ELB. So your website will be here, which comes in, hits this ELB, which will be distributing loads. It load balance these 3. Now, in case you are getting more number of users coming in, you can create additional EC2 instances right here. It may be 2, 3, 4, hundreds, any numbers which you wish to. So that's ELB, which does dynamic traffic distribution for you. And at the back end, you can increase EC2 number instances anytime, which your endpoint will never come to know. All right, so next is your storage services. That's which takes care of all your storage needs. Now, within your storage services, you have number of different storage services available. So first one is EBS, which you see on your left right here. Let me get this spotlight. Right, so EBS, Amazon EBS, that's the first one, which is something which is tagged to your EC2 instances. That means whenever you create your EC2 instances, you will be creating EBS volume with it. Now, we won't be going deep into it now, but when we create EC2 instances and when we'll create EBS volume to it, we will see what EBS volume is and how it is elastic. So your EBS itself is elastic, and we will be able to attach and detach it easily between EC2 instances. So that's something we'll be seeing it. But your EBS is called block storage, and that is something attached with your EC2 instance. So that's your EBS. It is a smaller unit within your all storage. Next is your S3. It is the internet scalable storage, and that's something you can use via API. So this is something which you can manage right from your console. So you can use it from as a web service. So you can do it from the web service. You can store images, videos, files, binaries, snapshots, about anything. Okay. Now, ES3 also comes with some additional feature called it can run a static website as well. So if you want to run a static website, you don't need to spin up a server. You can just run it on top of S3, and that's something we would be doing is as a part of one of our mini project or assignment which we have for S3 when we get into storage. So we'll be creating one of the static website and we'll be running on. We'll see that how to run it on S3 without actually creating a server. So you won't be creating a server, but your website still will be working.
Yeah.
Okay, next we have Glacier. So first one is EBS. As we know, it is something which is used with EC2, and you use it for installation and configuration of your softwares. S3 is not for that purpose, but that's something you store your bulk data. So you need something bigger storage unit, you can store about anything in S3. You can just create buckets and store it. Glacier is another one, which is more like archive storage. So S3 is a faster storage. You can push it into it and pull it from it easily. But Glacier is a bit different because it's archive storage. It is used for backups. So maybe you want to put your logs there. Maybe you want to put your database backup. So such wherever you have a requirement for archiving or backup, you make use of Glacier. And the reason for that is because when you put something on the Glacier, it is not easy to get that data back. I mean, when I say easy, it's like it is bit time consuming. So it's not so fast. Now, in the earlier era, probably about 2-3 months back, it used to take 30 minutes to fetch data from Glacier. But these days, for a slightly higher amount, if you wish to pay, you can get the same data within 1 to 3 minutes. So that's being made easier even in Glacier, which was not available earlier. So now from the Glacier as well, you can fetch the data within 1 to 3 minutes of time. But whenever you put something to Glacier, you need to fetch data. So it's more like archiving or backup. So you put a backup there, you need to archive it back. So you need to fetch data.
Okay.
So Glacier is used when you want backup mechanism. So you want something backup. So it's more like if you have a hospital running and you know that you want your customers won't be coming for a long, your patients won't be coming from 2 years back. You can dump some 2 years to 5 years or 10 years data on Glacier, and whenever you want it, you can take it back. So mainly so backup and archiving. Now, another one is storage gateway. And like I said, this is one of the services which you can use for S3 or Glacier. And that is something you use when your on-premises customer, they are interested in storing their storage to cloud. So
No.
mainly they have servers running, everything infrastructure is running on premises, but they want to make use of storage on the cloud. So they want to store data onto the cloud. They can make use of storage gateway, and that's where they make connection. So they will be making a connection between on premises and cloud, and they'll be storing their stuff onto the cloud. So that's for such a requirement, you will be using storage gateway. So yeah, different storage services for different needs. Okay, now let's come to database service. Now, in database service, the first one and the popular one, which most of the client would be using, is RDS. Now, RDS is simply called your relational database system, management system, those services, and you can see the examples of that: Oracle, PostgreSQL, MySQL, SQL Server. So if any of the databases, which is mainly in forms of table, they'll be using RDS. So if you have such a requirement, you'll be using RDS, anything for relational database service. Now, if you work with NoSQL, which doesn't use SQL, so mainly you don't use query, and it's a different database, which we'll be seeing as a part of our course when we discuss that. But if you have such a requirement, you'll be using something called Amazon DynamoDB, which is part of AWS itself. So AWS has itself released this service and is one of the most efficient one. And we would see the difference between RDS and Amazon, and why, which one is better, and what are the advantages of using one or the other, and when to use RDS, when to use Amazon NoSQL DB. Okay,
Okay.
so these are in terms of databases. The third one is Amazon Elastic Cache. Now, this is not exactly the database, but it's more like it's required for performance enhancement of your databases or web services.
In
Now, within
numerical.
this, yeah, so it mainly does the caching, and it can do the caching for your web servers, or it can does the caching for your database. So based on that, you have something called Memcache or Redis, so all those. Mainly what it does is in-memory caching services. So that's something it provides. So you can tag it to your databases, or you can tag it to one of your web servers. But yeah, why it is called database service? Because it does store data in form of cache, and you have that available. All right, then you have application services. Within that, you have CloudFront. So from this, although these are the examples of that, but we are going to discuss only CloudFront, which distributes your data globally. And that's something does using edge locations. It will be seeing as a part of our course. So we'll be creating this configuration as a part of our assignment, which we have for CloudFront. And then you have cloud search, where you'll be able to manage search services. Now, this is something important for the developers if they want it, or if they are making some coding for that. And transcoding, if someone is making use of video, if they want to transcode videos on the cloud, they can use it. But we are not covering these two, so we are covering CloudFront, which is required, especially when someone is working with websites. So it is important. Okay, now these are for big data services. We are not covering any of these, but this is just being highlighted to show you that these are part of your AWS service stack. So you do have these available. Now, there are quite number of other services, and we cannot cover all of them, but these are primarily at a higher level, because so that you know what it is capable of. Now, Within big data services, it has called Amazon EMR, which is Elastic MapReduce. It is mainly for your Hadoop. So if you're working with Hadoop framework, it provides you hosted Hadoop framework. Then you have AWS Data Pipeline. Again, it's similar to that. You can move data from AWS and between your data sources. So you have number of options available for your on for on-premises and AWS. You have Data Connect, you have Data Pipeline, which you can create. You have a storage gateway for storage activities. So you have at all levels. Then you have Amazon Redshift. This is mainly used when you're working with data warehousing system. So if you're really working with a bigger, data warehousing system, you can make use of Redshift, which can manage your peta-scale data warehouse service. Now it's easy, nothing so difficult in it, but yeah, there is a service available for it. And then Kinesis is one which is required for your real-time processing of streaming data at any scale. So if you are using a streaming services, you can make use of Amazon Kinesis. All right, now this is something we are going to discuss, which is deployment. Now deployment is, within that we have AWS OpsWork. That's your DevOps framework, and that makes users of your Chef framework as well, and you will be able to manage all servers as a group using your OpsWorks. So for now, I'll just tell you that when we do that, we will actually see that how it does it. So mainly if you want to change configuration for all of servers which you created, that's something you can do when you work with OpsWork. Similarly, CloudFormation, this is a useful service because this more like turns your infrastructure as a code. So you would have heard about that term, somewhere in the DevOps world. So if you really want that, if you want to create servers or spin up the whole environment in one go, for example, you have already created one environment where you have dev servers running, your application servers running, web servers running, you have created that. And maybe next time you really need the same environment, you can have that stored as a piece of code. You can create infrastructure code out of it, and next time you need it, you can just run that template and it will create exact the same environment for you, maybe for a different project. So that's something you can do it using AWS CloudFormations. Another one is your AWS Elastic Beanie Stack. It is also really useful for DevOps guys because it automates your resource management. For example, you have to deploy a particular application for Python or Node.js or for Java, any of these, right? It creates an infrastructure for you and you can simply deploy it without have to worry about what libraries to install or what servers to create and all. It just creates everything for you. And it also controls the versioning for you. That's the advantage. So it takes care of all your deployment needs. And then administration is where we will get into. So at this level, we'll be learning quite a number of things. So although in this slide, it just says administration, but we can segregate into a number of different things. We can call it management tools. We can also call security, things. So the first one, which you see on left, is your AWS IAM, which is identity and access management. That's where we'll be learning how to manage users, groups, permissions, roles, so everything, how to control your AWS resources will be the topic for IAM, followed by AWS CloudWatch, which is a management tool. That's where you learn whatever resources you create as a part of your AWS, how to monitor them. And then CloudTrail, which tells you how to perform audit or logging for your accounts within AWS. And then there is, this is something new to AWS, which was not available earlier. You have something called Workspaces, which is desktop virtualization the AWS way. And you can also get a desktop software for this. So using this, you don't need a hardware, you don't need a virtual software. You can access it from tablet as well. There is no monthly pricing, no long-term commitments. You can install software or bring your own license, and you can easily integrate it with MS Active Directory as well. So you have AWS Workspace available as well, which you can use it. So mainly if sometimes you want to do work with AWS on your mobile or tablet, you can do it. All right, so that's was quick introduction in terms of what AWS provides and what we'll be discussing in our course. So we have seen about regions, we have seen about availability zones, we have seen about edge locations, the data center within AWS. We quickly went through all the services which we'll be discussing as a part of our course. So mainly, if you can name it, it's like compute, your storage, your networking, your databases, your cloud management tools, your security, and your integration tools is what we have not seen, but we are also covering that. So yeah, so that's how it will go. So next session would be on EC2 instances. So again, the next day, because this is more like an overview, complete overview is what I've given you. Next, we will be discussing about EC2 primarily because we are going to start with EC2 at the first topic. So we'll be starting with EC2, the first topic. And as soon as that is done, mainly we will learn what EC2 is and what are the configurations available for EC2, how to create it, and what are the things you should consider before creating your first EC2 instance. Once that is done, we will start with demo. So once EC2 is done, we will be working with demo for some time. We'll be creating, because we have to create EC2, AMIs, load balancers, and everything. So we won't be having slides for everything, but yeah, something which is really important and you should know what it is. We'll be having slides for those, and then we will be working more towards practical approach of it. So next topic is EC2, where we'll be discussing about EC2. So we wrap it up here for today. So that live demo is for probably for the next session or the session after that, once we are done with EC2. So if we can finish with EC2 faster, we can go into the demo. If not, then we'll be going into the third session. All right, so tomorrow most probably we'll have session. I'll inform Firoz about it, but day after tomorrow and like on the Friday, I won't be available because I'm traveling. So I'm traveling to Atlanta, so I won't be there for like probably about 2 days, and then we'll be catching up again on Monday. But most probably tomorrow I should be here.
Okay. All right.
All right, so that's will wrap up here today, and tomorrow if you're connecting, we will be discussing on EC2, and then we'll go for an answer. Okay, so these slides you can check with Firoz. So mainly what we do, most of the slides and the presentation which we show on classes and the videos for the recordings, they are placed in the folders in the box.com. So you can get those details from Firoz. So whenever our session is done and whenever we raise slides, we all place all those things right there. So you can access it from there. So you don't have to worry about all these things will be available to you, and you can always go back to them and access it. That's just for your information.
That's
All right,
good.
thank you, Robert. Thanks, Rose. So we are wrapping it up here. Thank you.
All
Thanks
right.
for joining.
Okay.
Bye bye. Yeah.